Welcome everybody to this Leverhulme Wildfires guest seminar. Special guest today, Candice Charlton, who's from the University of West Indies, Mona. And Candice is a visiting researcher with us for 3 weeks. This is her second week, and she's going to meet many members of our centre and has kindly agreed to give this seminar today. And Candice is a researcher in applied physics at University of West Indies, and looking at bushfires in Jamaica and the Caribbean, and finishing her PhD at the moment as well. So a big warm welcome to Candice, and over to you.
Good afternoon. Good afternoon, everyone. Thank you so much for having me. I was slightly nervous building up to now, but I think it should be good. So as Dr. Ford said, my name is Candice Charlton. I'm from the University of West Indies, Mona. My PhD thesis is primarily around bushfire and climate change. I'm going to be presenting a bit on the middle portion of the thesis. I'm currently writing up the final paper to conclude. Right, and the title of the talk will be Evaluating the Skill of Meteorological-Based Indices for Determining Bushfire Potentials in Jamaica. So this research is being done under the supervision of Professor Candice Stevenson from the department. Prof. Michael Taylor and Dr. Jayaka Campbell also helped. Also helped in concluding this portion of the research. For the talk, just a quick outline of what will be covered. I'll go through some context of climate for Jamaica, kind of what we know so far about fires in Jamaica, the area that I'm specifically going to be talking about, and then just the general aim, again, restating that and defining a bit some of the indices. Looking then at our methods of the study, the research design, I'll go through some of that, some outcomes or results from the study, some takeaway points. I'm going to go through just an example use case of the main takeaway point, and then some concluding statements. I was told that not everybody is entirely climate, so I decided to just do some quick acronyms that will be popping up later on in the talk. So I will be talking about these. The TNA is the Tropical Northern Atlantic Sea Surface Temperature Anomaly Index. This is sea surface temperature across the Northern Atlantic Sea. Then we have the Nina 3, which is also a sea surface temperature anomaly. This is over the Eastern Pacific Ocean. We have the North Atlantic Oscillation. This is just the pressure distributions and interactions over the North Atlantic. And then I'll also mention a bit about the Tropical Southern Atlantic Sea Surface Temperature Anomaly. So I'm introducing these acronyms because a part of the study is done trying to determine if these large-scale climate and ocean patterns have any impact on the indices that I'm also investigating, because they have been shown to have impacts on Jamaica's fire weather and kind of climate and weather in general. So just to be able to make that linkage if it does exist. So just in terms of setting the context. So fire in Jamaica really became an important point of interest maybe in 2010 going forward, so in that decade, starting from the 2010s, with some marked interesting occurrences, as we're seeing here in the headline in 2014, where our coffee farms in the St. Andrew Hills were nicely devastated, causing losses of about $1 million. But then it continued again in 2015, coffees again were up in flames. Just barely enough time to recuperate any of the losses from before. Whatever was remaining and could become product, then again, it burns. Fast forward into 2021, we're no longer necessarily seeing it in terms of agricultural impact or agricultural industry impact. We're seeing where we're losing hectares of forest reserves to fires. 2023, we've literally started raising the alarm more often. Our Jamaica Fire Brigade has several different seminars, outreach to raise sensitization. We've also started on some project between the Jamaica Fire Brigade, the Met Service, and University of the West Indies to try to develop some early warning systems to help us to be able to manage better. Just a few days after, this March 9 headline, our Water Resources Authority is now also saying that bushfires are also affecting our natural resources of water. So we're having this kind of, as soon as it popped up as an issue, it's just broad brushing across several different sectors on the island. And so we are at this point of trying to really in these early stage understand what is fire weather in Jamaica, what the fire season really looks like. How are we really going to be able to track and predict and then better start managing these impacts that we're seeing from fires? And so my research is just trying to be able to start answering some of these questions and getting some of these frameworks and strategies and planning into place. Jamaica itself is a part of the Caribbean. It's in the larger Antilles. It's one of the larger islands in the Caribbean. And the general climate or climatology of Jamaica is one where we have local climates where our rainfall patterns are bimodal. So we have two natural peaks. However, when it comes to temperature across the island, with the exception of the parish of Manchester across the island has pretty much similar temperature, always on average ranging in between, say, about 27 degrees Celsius for most of the parish, with the exception of Manchester. Though we have a bimodal rainfall patterns, we actually have distinct rainfall zones on the island that you're seeing here. So we have 4 zones. Our interior zone, zone 1, is the middle backbone of the island, which is mostly our forested areas. Then we have zone 2, which is specific to Portland, and Portland has its own zone, mainly because though it also has a bimodal pattern, the peaks that it has are at different times as opposed to all of the other zones. And we have zone 3, which is our western zone, and our coastal, northern, and south coast makes up zone 4, which is historically our driest portion of the island. This local climate is driven by some of those same things I mentioned to start off with, our acronyms or large-scale atmospheric and oceanic patterns, such as TNA and Nino 3. These play a role, especially when we start talking about ENSO or El Nino effects, play a large role in how we experience rainfalls or drying, whether regularly or in the extremes. And all of these combined together have been shown to impact what we can call fire weather in Jamaica. For the study specific that I'm going to be talking about, the region that we're going to be looking at is in the south central Jamaica. So I'm going to just use the pointer. So it covers Manchester, Clarendon, St. Catherine. It actually borders a portion of the coastal zone, zone 4, and a portion of the interior zone, zone 1. The general aim then is really to be able to evaluate the Cage Barham Drought Index, water potential, and vapor pressure to determine fire potential across the island, starting off specifically to look at this particular subsection of the island where we had enough available data that we could use to validate satellite data sets that could then be used to run the analyses. The Cage Barham Drought Index specifically describes the interaction between the atmosphere and the soil. So it's a measure of drying in the soil. Whereas with water potential and vapor pressure deficit, it describes more the atmospheric interaction with the plant life. So for the research, the data set that we used was the MODIS C6 fire archive data sets. We also utilized some years of the Jamaica Fire Brigade data sets. For MODIS, we looked at 2010 to 2019. Well, we had the larger 2001 up to 2019, but we're specifically looking at 2010 to 2019 because it's closest in overlap for the short amount of period that we had for Jamaica Fire Brigade, which was just from 2013 to 2017. In order for us to be able to actually use the MODIS, we did do some comparative analysis to check how it actually fit with the variability of what we did know for fire based on Jamaica Fire Brigade data that they had. One of the things that we did note was it was representative somewhat of the climatology and the normal trend, but it did underestimate in terms of numbers when we did some assessment in terms of like the difference on a factor scale. If we multiplied it by a factor of 30, we saw that we still maintained the trend and it's somewhat represented better that monthly variation. That's what we're seeing here in the diagram. So we use the MODIS C6 data as our fire data reference for all of what we're going to be looking at in terms of the analyses and the results. And the Jamaica Fire Brigade data set was used in some of the categorical analysis and then also in some of the other relationship analysis, just to ensure that what we were seeing from the MODIS was still kind of holding true for what we had for that short span of observational data. And then all of our meteorological variables, our temperature, rainfall, relative humidity, was coming from ERA 5. So we started off by calculating the indices. They are normally calculated daily, but we aggregated them to monthly and seasonal time scale. So a lot of what will be presented will be in terms of specific seasons or climatology or monthly distribution. For the Cage Biome Drought Index, the inputs for that would be daily rainfall, daily maximum air temperature, and average annual rainfall. For water potential, the inputs is daily maximum air temperature and relative humidity, while for vapor pressure deficit, the inputs for that is daily maximum air temperature, relative humidity, saturated vapor pressure. The thing to note, specifically while I was doing this research, something that stood out a lot when it comes to these three indices, more so the difference, and we'll see it playing out a bit in the results, is that the Cage Biome Drought Index is really heavily based on different time scales of rainfall, whereas with water potential and vapor pressure deficits, the key here for me would be the relative humidity, and it does show up a bit when we get into the results and how they really interact or relate to what we have as our fire data. Mainly because I think because water potential and vapor pressure is specifically related to the vegetation and not just to the soil, and a lot of vegetation in the areas that are having issues are either just specific crops or shrubs or then specific forestry or tree types, but they're still both burning at different times and at different scale. It showed up being something that to me was very noteworthy, that these two being more specifically related to the vegetation definitely showed up as being more useful, but we'll speak to exactly how that played out. In looking at how representative each of these three indices were, we looked at visual representation of the normalized climatology, and then we also looked at identifying relationships using correlations. So R-squared values, p-values. We looked at categorizing the skills of the indices, and the Cage Biome Drought Index risk level skills are known and well documented, but specifically for us in terms of breaking down what the risk levels would be for vapor pressure deficit and water potential. What we looked at is a document that we periodically update for Jamaica, and we also have a Caribbean version called State of the Jamaican Climate, where we have specific boundaries as to what our normal temperatures are and our normal humidity levels are. And so using those boundaries that we have as our normal minimum and our normal maximum for temperature and relative humidity, we calculated the vapor pressure deficit and the water potential. And then we found the break down the different sections into low, moderate, high extremes between those boundary values. So the risk levels that you're seeing here were created in that way. The categories here then are then used to find out whether or not when the Jamaica Fire Brigade in their short time span said that they had more fires in a particular month or less fires in a particular month, if the indices were able to actually pick up the same risk levels based on the calculated values and the risk classes that are in these tables. So we did that by finding the hit rate and the false alarm rates to determine if it was really able to pick up and accurately identify by month with the information what was really the risk levels in these particular areas over that period of time. And we also did some final assessment with the fire directly, how it relates to the risk levels. This was just done using linear regression to see if there is any actual predictability when we start using these indices for the fire. And then we also looked at the indices finally and how they had any relationship with those large scale drivers that we already know were driving our actual climate in Jamaica. So some of the outcomes of these results, just looking at representativeness, we have two panels here. We have one that looks just on the South Central, and then we also have one that is all island. We're showing here both the MODIS and the Jamaica Fire Brigade climatology. And as you can see, we have a peak for fire in March and then a secondary peak in July. And then if we look at the climatology that is presented for Case Biome Drought Index, water potential, and the vapor pressure deficits, we're seeing where on both just looking at the South Central, or if we look at the actual all island, we're seeing where we have our first peak in March and then the second one in July, or water potential, which is shown by the symbol psi here, and our vapor pressure deficits are more aligned with what our actual fire climatology is, whereas KBDI actually is showing 1 month lag, so it actually has its peak about 1 to 2 months after we actually have our regular peak climatology for our fire. Just looking at, again, the climatology again, and also the monthly variation, the Case Biome Drought Index actually is more correlated to the MODIS. However, because the MODIS is only partially correlated to the actual observed data, that just kind of shows one instance where the Case Biome Drought Index might not necessarily be the best indices for us to use. Whereas water potential has agreement with both MODIS and the Jamaica Fire Brigade observed data, more so with Jamaica Fire Brigade, but it works for both. There is statistical significance both on the monthly variation and the climatology, but as you can see, the actual relationship is higher for the climatology more so than the monthly variation. But the categorical assessment looking at hit rate and false alarm rate, I'm just going to key in on this slide specifically on Mason River. So Bodles that we're seeing here is representing a station in St. Catherine, Mason River is representing a station in Clarendon, and Grove Place is representing a station in Manchester. So it's one station from each of the parishes that makes up the South Central subsection we're looking at. Right, so just looking at Mason River, and specifically at Mason River, because with Mason River, as the name suggests, the community is actually by a river that is called Mason River. So we noted that KBDI did the best here in terms of picking up low risk. So each of the time that the Jamaica Fire Brigade said that there was fire, but it wasn't high risk, there wasn't a lot of fire, KBDI did well, but it still had some issues, as we can see with the false alarm rate. But notably, none of the indices picked up any extremely high risk, which makes a lot of sense, since it, even though there might be extended drought conditions or drying or excessive changes in relative humidity or rainfall in that particular location, because it has the natural river as a waterway to feed the vegetation, there might not be as much impact from those normal atmospheric conditions that actually have extremely high risk factors. So it's good in this case that it was able to segment out the difference in the topography of that particular location to say that none of them were picking up extremely high, because you wouldn't, unless under some extreme condition, you wouldn't expect that location to have extremely high risk based on what is available in terms of additional water separate from rainfall. But then just looking at when we averaged out all three locations to just have a look at the South Central distributions, we can see where water potential and vapor pressure deficits, and it would have been obvious a bit from the previous table, that they do not do really well in looking in identifying low risk, but they do a lot better than KBDI in identifying extreme risk, which is very important for us because what we're trying to avoid is having extreme cases and extreme losses. So although they're all having a large false alarm rate, that also makes sense since we're looking at one specific indices that is tracking only one specific thing, and fire itself is dynamic. So the false alarm rate is not so concerning from that aspect, but its ability to still be able to pick up some of what is risk based on comparison with the observed data. So under or other analysis, so this is just us doing the linear regression to see if there's any predictability of any of these indices. And we're going to be looking at just two seasons. So April, May, June is our first wet season. And then we're going to look at July, August, which is one of our dry season. So straight away from the table, we can identify that, again, water potential and vapor pressure deficit, which is more linked with what is happening to the plants due to atmospheric conditions, are doing better than the Cage Biome Drought Index, with vapor pressure deficit doing slightly better than water potential from a R-squared relationship perspective, and also in terms of standard errors. For our July-August dry season, we're seeing where Cage Biome Drought Index is actually doing better than it did in the wet season, but it's still not doing better than the vapor pressure deficit and our water potential. Our water potential doing slightly better in terms of R-squared, but still has a higher standard error than our vapor pressure deficit. One of the things I noted with looking at the fires seasonally is that the change in relative humidity that we have in terms of going from our wet season to our dry season, and then if there is any extended drying in what would have normally been a wet season, which then impacts the relative humidity, seems to be what is allowing vapor pressure deficit and water potential to come out, even in the wet or the dry season, as being better potential predictors. Because the period that we're looking at here, and in the example case, I'll speak a little bit about it more. The period that we're looking at here between 2010 to 2019, in the middle of that period, from about 2013 to 2016, the Caribbean actually experienced one of the longest multi-year drying drought that is ever seen. So even in what would have been our rainfall season, it was not a typical rainfall season. So it's just seeming to me that what is playing a large role for us is that change in relative humidity that the island is not used to. Because our boundaries are pretty specific. The lowest our relative humidity gets historically is about 59-60. It doesn't normally get any lower than that. So anything that allows it to be going lower than that for extended periods of time then becomes more of a trigger for us in terms of what we're experiencing now as this increasing continuous kind of fire from year to year. And so then it really made sense for us to look at those large scale drivers, because a lot of what happens in the Caribbean in terms of or experiencing drying or rainfall is really characterized by those large scale drivers and El Nino and sea surface temperature changes that affects distribution of moisture throughout the Caribbean. It affects our evaporation rate, which then affects our relative humidity numbers. And so all of the indices were showing some relationship or another with looking at the difference between the tropical North Atlantic sea surface temperature and the Eastern Pacific sea surface temperature, Nino 3. And we're actually bordered by both. The tropical North Atlantic is on our top right and Nino 3 is on our bottom left. So we're right in the middle of these two sea surface temperature warmings. They are also significant with them individually, but we know from previous research that the difference between the two is definitely a driver for our fire weathers, because the years that we had the most fire is when we had more of a difference in what is happening in the tropical North Atlantic versus what is happening in the Eastern Pacific. So for us, it's very important for us to be able to capture or keep track of anything that changes what is happening in terms of El Nino effect in our region, since all our rainfalls, dryness, hurricane patterns are all influenced by what is happening in sea surface temperature. Some influence that we also have is from the low level wind as it passes through the Caribbean. There's also some influence in how hot air passes through, and when we have hot air and cold air pattern set up. So our climate is really predicated on what everybody else around us is doing, because we're in the middle of everybody else's motion, so to speak. And it shows up very much so in the fire weather that we have and the type of risk that we're now starting to have for bushfires in Jamaica. So just some takeaways from the results. Some key takeaways from the study. So the results definitely suggest that the water potential climatology exhibits strong correlation with both the satellite data set and the short observed data set that we had for fires. It represented the peaks of March and July well as the minimas that we have during May, June, and in October. When we did the categorical assessment, again, water potential and vapor pressure deficit had good hit rates when it comes to identifying moderate and high risk categories, which is very important for us. When we looked at if there was any predictability using the regression models. The water potential and vapor pressure deficit also showed good skill, more so on the seasonal trend, not necessarily more so monthly, but if you were to track it seasonally, it had good skill in tracking it seasonally. All of the indices had a statistical significance, both monthly and with a 1 month lag time series with or large scale patterns, linear 3, and the difference between the TNA and linear 3. The highest correlation being minus 0.5 for the Cache-Bram drought index when it's run concurrently with TNA minus linear 3, and for vapor pressure deficit and water potential, the highest correlations came when we had that 1 month lag where TNA was leading the calculated indices. So the major output, and it's definitely fed into the final portion of what I'm doing. So the example that I'm going to go through is kind of a simplified use case of how the third portion of my thesis started, not necessarily how it ended. And so we're just going to look at testing if we were to just actually try to calculate the numbers of fire that it said it would predict for like a July, August season, what it would be. So since we're just testing everything from scratch, we just put back all of the indices that we're starting with and just did some variable selection. The methods that are used in that third part, we did elimination regression, as well as we attempted to do a lasso regression to see if either of the two methods would give different results. Again, it substantiated, if we're looking just on that July, August season, that water potential would have been the choice. So then we put water potential in a generalized linear model and compared what it predicted to what the MODIS value would have been over that period. And the time period that we're looking here is 2011 to 2021. So we're not just sticking to 2010 to 2019. We've kind of just expanded it a bit to just see what it would be. And as we can see from the diagram, the predicted fire during that period for July, August is decently, I would say, related to the actual original. It has a 0.66 relationship that is statistically significant, which to us is saying that if we were to choose to use just water potential, it would be useful for us in terms of seasonal forecasting. But of course, the long term is be able to have a fully working early warning system, not necessarily just for specific seasons, and being able to also do some long-term projections. So water potential definitely for us is a good predictor that we can look at. And that means then coming from this, if we were to add water potential and some other variables that are also useful for predicting fire in an early warning system or in a long-term outlook, that would be very beneficial then for Jamaica going forward in being able to manage, track, risk, and deal with fires agriculturally, as a risk to the rest of our natural resources, as a risk to forestry. It would put us in a good place to be able to get ahead of the potential impacts of increasing climate change and what that means for increasing fire activity or decreasing fire activity. And with that, thank you.
Thank you so much. Oops. Thank you so much, Candice, for an excellent seminar presentation. Open up to questions to the room or comments from anybody.
Any help?
Or yeah, any also help. I'll check online as well and see if there's anybody. But yeah, Olivia.
Hey, yeah, thank you. I was just wondering, that slide you showed at the end with the GLM, that's just the water potential. What timeframes and data did you train that on? Because you're showing it as like yearly. But was it on the seasonal or the climatology? Like, what was it trained on?
So it was the same July-August season for the preceding year. So from 2001 to 2010 was the training year, and then the prediction was 2011 to 2021.
And you're using the previous July, like it's
July-August. So all of
Yeah,
it
yeah.
is July-August.
Cool.
Yep.
Thank you.
Thank you for your talk. One thing that I noticed is that, for example, for Brazil and the Amazon, there's a quite well-established early forecasting system that is basically based on the NAO and God knows what, and other of these things like with 2 or 3 months lag. I was just wondering, did you actually just basically tested those indices with the actual fire activity rather than going through the indices? Because that would be a more direct thing to do, and maybe that would tie in what they.
Right. So these indices were tested originally. The first phase was to kind of sort of characterize Jamaica's fire weather or fire season, because there wasn't any real understanding of what was really driving the fires. We just started having lots of fires. So those large-scale climate and oceanic patterns were tested initially first just on fires. And so coming out of the testing on just fires, for us, we're still seeing where the Nino 3, more so the tropical North Atlantic minus the Nino 3, that interaction between both that we're bordered by was one that showed up as being a driver. We also had, depending on the zone, so depending on the rainfall zone, because there are 4 rainfall zones, we also had some relationship with the North Atlantic Oscillation, NAO, and also there was some periodicity that was found there. So there was some correlation with the Atlantic multi-decadal oscillation, because we found that depending on the zones that we're looking at, there were different periods of fire. So there was kind of like a change that we could have picked up on, like every 3 to 5 years, there would have been a change depending on the rainfall zone, or every 5 to 6 years, depending on the rainfall zone. You can actually get more information specific to that on the first paper, but we did actually test them directly on the fire data before testing it on any of the indices.
Lots of questions here, so I think we'll do it.
Thank you. That was really interesting. Thank you. The UK Met Office in Britain, they basically use some sort of subset of the Canadian Fire Weather Index to assess fire risk across the UK. It was basically originally to close land. So we had a lot of land that opened up in about the late 90s for walking, and the Countryside Agency had to be able to close land at times of extreme fire risk. So they used this particular index to identify extreme conditions. We did a bit of work with them, and it was basically, if I remember rightly, they originally used the same thresholds across the whole of the country to say what was extreme and what wasn't. And we did, relatively simple things where we just basically looked at percentiles. So we gridded the country and then basically looked at, the statistical distribution of these indices, and then said, are you in the 95th percentile in July or something? Because what might be extreme fire index in wider index value in Scotland might be, quite normal in southern Britain or whatever. Was that something that you did? I couldn't quite get it. I probably missed it at the start of your presentation, where you had the values of these different indices. Was an extreme condition set as a particular, individual value, or did it vary by location across the country? I think that's my question.
So The case for drought index risk is set, but specific for the vapor pressure deficit and the water potential, it was set at a specific level based on historical climatology. So it was boundaried by what we knew to be our maximum in a particular, say, maximum temperature, minimum temperature, maximum relative humidity minimum. And then we just use that as the baseline.
And does that change across the country? You showed like 4 or 5 different zones, I think.
So I think it holds true most for the southern zones. Those values hold true most for the southern zones because they tend to be hotter or drier, but more so than when it comes to, say, Portland, which is its own sub-ecosystem where rain falls every day, just like in London. So for Portland, it doesn't necessarily hold. There needs to be different variation to capture that. So like in the final portion of the study, before finishing, say, the statistical model, we also did a testing on looking at NDVI and NDWI and what those vegetation indices might show or might not show. And we also looked back on, instead of just the subsection that we started off with to test what would or would not be suitable, we actually opened up to the entire island, then getting data from all the parishes. And so the final kind of selection of variables is quite different. It still has water potential, it still ended up being in there, but there were some other variables that I think accounted a lot better for, say, or zone 3 and or zone 2 in Portland than it would have if we just looked at what zone 4 produced as a potential predictor.
Okay, thank you very much.
So I'm curious about the water potential. I'm used to thinking about water potential of either plants or
Yes.
soil, but is this the water potential of the air, or what it is?
Right, so the water potential that we're looking at here is sort of this, so the water potential that we're looking at here is sort of describing what is going on in the plant. So the plant's ability, for lack of a better word, of how well it can sweat depending on how atmospheric condition changes. Because if the transpiration of the plant is diminished in any way, shape, or form, then movement of nutrient changes, its ability to cope in its regular environment changes. So that's kind of what we're looking at for water potential.
So how do you calculate what's the inputs?
The inputs for the water potential that we calculated was maximum temperature and relative humidity.
Okay.
Something early.
It's challenges us all.
Yeah.
So, I mean, if you don't do it to me, then you prove it's only calling me a name.
Yeah, it's bringing.
So, thank you. Very nice talk. Very clear. First question is, do you think, I mean, is the TNA in some way correlated with El Nino? Because, you took the difference of the two. And surely there must be some connection.
Yes.
So maybe describe it to us. And then the other thing, knowing the landscape of how policy is made in Jamaica, what would be your expectation in terms of take-up of what you're doing? I mean, would you think that this is a tool that can be easily communicated and then uptaken by the policymakers or civil protection agencies and so on?
Great. So on the first question, so there does seem to be linkage between the TNA and the U3. I didn't really do set in-depth studies to kind of look at what that real kind of correlation is and how they feed off of each other. But there does seem to be a linkage between what they're doing at different times. Specifically in terms of uptake from policymakers. there's definite interest in terms of policymakers. I have worked with, and I still currently work with, the Jamaica Fire Brigade in some capacity and the Meteorological Service of Jamaica. The current prototype, I would say, of the early warning system, it's not operational, but we've been testing and trying. As I've been going through the PhD, I've also been helping them with that because they've been trying to work on that. So we are slated to get back working on that to make it actually fully operational, either ending of this year into next year. So they're definitely working on making that into an actual usable product. From more so, say, a policy standpoint, I still think that the previous version of fire management that for Office of Disaster Preparedness and Emergency Management does need some updating. So there will be some talking to see how that can be changed based on new evidence and new information from this study and ongoing studies about what is really happening. But there is a definite drive in Jamaica in terms of being able to make all of our sectors more climate resilient and more sustainable in a sense, because we heavily depend on tourism, and then all of our other sectors kind of just feed into us being nicer where tourism is concerned. So for instance, coffee is an export for us and it's well known, and so we want to make sure that that happens. And the Coffee Association is very interested in funding projects to being able to determine how to monitor their farms and plantation properly, to be able to know which variables to track, what type of census to get, to really put in full scale system. So there is a lot of room for uptake and interest in being able to manage well. I still think more so though on if there is tons of interest in funding the research itself, that maybe not so much, but in being able to access the outputs of the research, definitely.
Brilliant presentation there. Thanks for that. Besides the kind of meteorological factors that you were looking at in terms of trying to develop this risk index, what are the other drivers, or how much of a contribution do you think would come from the land use activities that might have contributed to the spikes of fire that happened or that you're experiencing?
I definitely think that changes in land use over the years have also contributed to increases in fire. When I go back, if I can remember to email, I will though. I just need to follow. So the 2023 updated GIS land use map has been completed by the Forestry Department, which I'm supposed to be getting a copy of. We were emailing before I left, but then the difference, I haven't been able to follow up with them. So the aim is to be able to incorporate that to see what it was before, like the 2010 version compared to what the 2023 version is, and how that might have affected how fires now in certain communities that it perhaps was not in before. Is definitely something I'm interested to look into, because there is, I would say, a link between that, where my house currently is right now in Old Harbour. On the way to Old Harbour on the highway, there are fires all the time. There are literally signs while you're driving on the highway to just remember this is a smoke area. Be careful, all these things. But then the area was actually cleared so that it could be developed, so that there could be a highway, so that the house that I live in could now be there. And so there's a lot of things that was done in the name of development that changed how a lot of the areas were originally used. A lot of it were just open pasture lands that were surrounded also by smaller agricultural farm, but it was just, there are lots of areas in Jamaica that when they're undeveloped, it's just like lots of mango trees and random trees, and nothing is there except just trees and grassland. So when they then go into develop and then they remove those larger trees and they start changing things, the neighboring communities that are close by now have more free land or cleared land. And then that changes now how they were using the land before. So I do think that there is a link between how fires are increasing in particular communities that definitely needs to be investigated.
Thank you. Any further questions or any comments? I think she's got another one.
So now now that there is kind of an evidence that there is increases in fires that you're kind of getting, are there any practices that have been put into place to kind of counter, like having fire breaks, maybe controlling fire, like regulating the use of fire for certain seasons and all of those kind of things?
I like how you said regulating use of fire. So in Jamaica currently, and forever since, it is actually illegal to just randomly burn things. It's actually not legal. It stops no one though, because it's one of those laws that rarely gets enforced, but it's actually currently illegal to just light fires anywhere you are. You're not actually allowed to do that. So regulation already exists in terms of just lighting fires. There are, however, cultural practices in terms of when it comes to agriculture, but the persons that do those also keep abreast of whether or not it's drier than it would normally be, or if rain is coming at normal time, to help determine whether or not they're going to clear their fields or not. So I don't think that that's necessarily increased, so to speak, from a cultural aspect. I do think that there is more. As I said initially, the Jamaica Fire Brigade has actually increased its public outreach and education campaign. It's also increased its teaching. It has a fire management program that it does in specific communities, and it teaches them how to create the fire breaks, because we have some communities that are literally, you go outside and you're in a forest setting, especially for those that are in the interior of Clarendon. That's the setting. And then for areas like in St. Andrew, where we saw the clip about fires, specifically like Mavis Bank, there was, when the first set of fires started in that area, there was a full campaign in getting them to learn how to really manage the land and treat with the land and fires. And it did actually help in reducing the amount of occurrences in that particular area. So there is still some work to be done in terms of getting to the specific communities. But I do think it probably needs to be a lot broader than that. And until there is, I would say, infrastructure change in terms of how disaster preparedness works, then it might not be as wide scope. But there are specific communities that have benefited from some of the Jamaica Fire Brigade interventions.
Okay, thank you. Yes? Huh?
Yes, a simple question. Why did not try directly the fire weather index? You split KBDI, which is somehow the cross code. The other ones are somehow the daily air humidity, and the fire weather index directly combines everything. So why?
Interesting question. To be honest, when I started this thesis, because my professor, my supervisor, is actually a professor of climate studies, atmospheric physics. So this was kind of a new idea, new topic for us. And at the time, specifically, the Met Service was interested in developing something, and they were reading up on the Cape-Brown Drought Index, and so they were interested in it. So we started off looking only on the Cape-Brown Drought Index, because we have a partnership between our climate studies group and the Met Service. So we started off just looking at what they were interested in. And then as I got into the research, I started finding other things. I did eventually get to looking at the Canadian system, but at that point I was actually quite well in the weeds of the thesis, so I opted to just finish the thesis to submit it for what it is as a project. The aim is to actually be able to find complementary systems that will be able to help us, because as I said, not every particular area is the same, and though our climatology is kind of broadly uniform across the island, we do have some microclimate pockets that are very specific to that location that we have to take consideration in. And one of the things when I look at, say, a FWI that is from, say, Canada, that has way different type of species of plants as us, and different ecosystem and clearly set out seasons, which we have wet season and dry season, that's our season. I'm a little hesitant to just directly apply that to us, right? I'm more interested in taking from it what are the good parts of it and then apply it into our context. That way it might suit us and be more applicable than just trying to directly apply what they already have based on us as an island.
We've lost our chair.
Dealing with catering.
I think those.
Just following, just following, I've got just following up on that. I mean, of course, I was had a student some time ago, and it's in his paper. He looked at all of the different fire weather indices, and one of the things that he demonstrated was that, you know, the Canadian fire weather index does really well for Canada, and the Australian fire weather index does really well for Australia, and so on and so forth. And so I think you're very right to actually have a Jamaican fire weather index.
Thank you, Sandy. Yeah.
So since we're now designing the Jamaican Fire Weather Index, what are your next steps? What would you be putting in there in your sort of dream world? What do you think you're going to be looking at if you're doing a postdoc carrying on from this work?
What would I be looking at? That's a very good question.
You might want to come here for a postdoc.
I don't know, maybe. I think for a postdoc, what I'm most interested in doing is just getting a better understanding in, I guess, all of what I've already been playing with, to be honest. I'm executing this research from the standpoint mainly as a climate scientist. So there's a lot of the fire that I've just been learning, and it's not really accessible expertise. So I would say it might take me a while to frame out a particular project for postdoc, but I'm definitely interested in continuing and developing and being able to really have a Jamaica fire weather index, because it will definitely be most helpful for us. But I don't think I can currently answer your question.
The final questions. That's one major.
I'm quite curious to kind of know how will this, or like how will your project be then kind of implemented going further? Because you mentioned that when I asked about, the regulations and the control, that it sounds like most of the banning is mostly known by culturally the farming community in Jamaica. So now I'm kind of interested to know, because if you're introducing these kinds of tools, it will help to inform the policy. So it will come as a form of institutionalized way to regulate or to control fire management. And then that usually comes with, there's always a challenge for it to be accepted by the people on the ground, especially if there are land issues, particularly when it comes to tenureship or land ownership. I'm curious to know what are your thoughts when it comes to the receptiveness of the community of these kind of policies that would be that will be kind of supported by your current project, and what would be the influence of land ownership and tenureship, because these tends to drive or kind of overlook the already existing structures that communities have to regulate their fires. When you're introducing these new policies, then it becomes a problem. So how do you anticipate that?
Well, as it relates to kind of land ownership, there are two groups. So there are small scale farmers that will farm on their own land. there are farms that are kind of generationally handed over. So for instance, my grandmother is actually from St. Elizabeth, where we live in St. Elizabeth, where I hardly visit. We have a lot of land. So my extended family that lives there farm on the land, both livestock and crops. And then they'll just keep doing that because they're their own land. Then for other persons that want to go into agriculture, they will lease land, lease private land, or they will become a part of the national agromate system. So we have large agromate farms that individual farmers farm at, but it's kind of like a collective. So it's like a collective setup. So in terms of ownership and tenureship, it's fairly structured. I mean, it's a Caribbean island. We still have squatting and those kinds of settlements, but for the most part, when it comes to agricultural practices, it's fairly set up. Persons just lease the land. The leasing is normally done fairly easily, and then you get to utilize the property. As it relates to institutionalizing, say, sort of outputs or policy changes that could be informed by the outputs, one of the things that I've noted, especially when it comes to our agricultural sector, and it might just be the portion of the sector that has favorably decided to partner with the government through an agency that we have that's called RADA, Rural Agricultural Agency, is that the farmers actually want us to provide this information, because what they don't want is to be investing a lot of money into the crops and then cannot yield anything. So in one of the last forums that I attended before coming here, it was our first national climate forum, and we had everybody at the table, and they were asking not just for the regular 3-month forecast, they were asking for 2-week products, because if they're planting the seedlings and then they hear, oh, next 2 weeks is going to be dry, the seedlings go. So they're asking for not just our regular products or regular intervention, but shorter term information. So there's definitely an appetite to have the change and have the structure, because it actually helps their bottom line. There has been a lot of work in Jamaica. It's not fully functional, but there has been some work in the financial sector to provide insurance for persons that are farmers. Only a few banks currently offer that insurance or loan, but it's something that we've been actively working on. So for the farmers, and I can speak to that subset because I haven't spoken to every different category of farmers, for the farmers that actually are already engaged through the government agencies or any of their programs, they're very keen to have this kind of information, because it helps them to safeguard their investments, because farming is legitimately a business. It's even for persons that do it as hobbies, when they see that they can make money, it becomes business. So I don't think there's much pushback in terms of if it becomes an institutionalized change.
Brilliant. We're going to finish there. Thank you so much, Candice, for it was an excellent talk and great questions from the room as well. So thank you very much. It's been a pleasure having you here. So there is more coffee now out in the corridor. So please do enjoy coffee and do talk to Candice and each other. And thank you so much for being here today. And I'm sure we'll be meeting again soon. You know, remind you in person for the next meeting. Thank you, everyone.